Question number 16, it says 8 cards are numbered from 1 to 8. They are placed in 2 boxes such that the sum of the numbers on the 3 cards in box P is equal to the 5 cards in box Q. So which of the following statements must be true? Alright, so if the 8 cards are from 1 to 8, it means that the total in each box is half the sum of everything, right? So it's half of 1 adding all the way through 8, which is going to be 8 times 9 divided by 2, which is 36 divided by 2, which is 18. Alright, so now we know that 3 cards in box B adds up to 18, 5 cards in box Q adds up to 18. So how do you make 18? You can either do 5, 6, 7, or you can do 4, 6, 8. Of course, you can also do 3, 7, 8, and that's it. There's no other options because the 3 can't get any smaller, and of course, 8 can't get any bigger, right? So that's all the options we have. And now let's take a look at the 4 options. The card numbered 1 is not in box Q. So these are all for box P, okay? Of course, it is in box Q, which means A is wrong. The 4 cards in box Q must have even numbers on. There are a total of 4 even numbers, but at least one has to be in P, which means that that's wrong. The card number 5 is in box Q. Well, we are not sure about it because it can also be in box P. So let's leave it for now. Oh, it says must be true, then we can just delete it. The card numbered 2 is in box Q. That's definitely true because there's no 2 in the box P at any occurrence. So the answer is D. And let's take a look at the last one. Exactly 3 cards in box Q have odd numbers on. Not necessarily. Alright, so that's question 16. And then for question number 17, it says that this diagram shows a square, an equilateral triangle, and a regular pentagon. What is the size of WUV? So we can just try to sketch a line right there from W to U and then back to V. Alright, so that's what we have. That angle is what we're looking for. So for a square, an equilateral, and a triangle, and a regular pentagon, the common property is that all the angles are the same and all the sides are the same. Which means that this is going to be a 60-degree angle. This is going to be a 30-degree angle. And this is going to be a 108-degree angle. And these two sides are the same, which means WUV is an isosceles triangle with a 138-degree top angle. So the base angle is equal to 180. Take away 138 divided by 2, which is 42 divided by 2, that is 21. Okay. That's question 17. As for question 18, so this is like a simultaneous equation grid. We want to find the value of spade adding diamond subtracting club. So we can observe this table first to see what is different there. So if you look at the first column and the first row, you can see that they are 53 and 52, just because a diamond has been swapped for a spade, which means that a spade is equal to 1 more than a diamond. So I can replace that for 1 more than a diamond, and we know that 3 diamonds is going to be 51. So diamond is 17, spade is 18. Now knowing that, we can put 17 and 18 there to find out the value of the clubs. So it means that 35 adding clubs is 47, clubs is 12. So we can calculate that. Spade adding diamond take away clubs is equal to 17, adding 18 take away 12, which is 35 take away 12, which is 23. Okay, so that's for question 18. As for question 19, well, it says that PQRS is a square of side 10 centimeters. The distance MN is 6 centimeters. And, well, it's divided into 4 congruent isosceles triangles, which means the 4 triangles are the same. 4 congruent squares, which means that these squares are the same, and the shaded region. And we want to find the area of the shaded region. So first of all, if these squares are all the same, they should all have a side length of 2 centimeters, 2 centimeters on both sides of the 6, such that it adds up to 10, right? And then for each of these 4 isosceles triangles, you can see that they can be put together to form a square. Right? So it means that I am just doing 10 squared, take away 6 squared, take away 4 times 2 squared, which is 100, removing 36, removing 4 times 4, which is 16. And that is going to be 48 square centimeters. All right. Okay. Oops, why was I going back to the last one? And let's take a look at question 20 now. It says that the diagram shows a 2x4 table in which the numbers in each column, except the first one, are the sum and the difference of the numbers in the previous column. So it means that this one comes from 10 adding 3. This one comes from 10 subtracting 3. So the next one is going to be these two's sum and these two's difference. So what you can see is that for every skipping column, the two numbers are going to double themselves. So we can use that finding in a 2x7 table in the same way and obtains the number 96, 64 in the final column. So if I have columns 1, 2, 3, 4, 5, 6, 7, and the last column is 96, 64, what are we looking for? We are looking for the sum of the numbers in the first column. So actually, the first column is going to be half of the last number, which is an eighth of column 7, which means that the sum in the first column is going to be an eighth of 96 adding 64, which is 160, which is going to be 20. All right, so B is the answer. If you don't believe me, of course, you can just trace it back step by step and see if that works. All right, I'm not going to stop you from doing that, but it's the easier way of solving this question once you discovered the pattern. So that's question 20.